Hey, welcome back to Math with Patrick. Today is November 15th, and we're solving problem 319 from the Daily Epsilon calendar. And the answer today should be 15 because that's today's date. So we should try to figure out why x needs to be 15 for today. So we have a system of equations. There's one equation here, one equation here. We have two unknowns. We don't know stuff about x nor y right now. And then usually if you have the same number of equations and unknowns, it is, again, usually possible to solve for them. So I do have hope that we can find a value for x and for y. Looking here, this is a kind of complicated equation. We have the difference between our two numbers divided by the square root of a kind of complicated expression. And then I'm just trying to figure out some stuff about x and y just by looking at this equation. I do know that square roots can only return positive numbers. And so this numerator also needs to be positive because once we do a positive divided by a positive, we're getting a positive 2. And so there's no way for this number up top to be negative, or else we'll get a negative result from the fraction. This does tell me that x is greater than y. And there's a few things that could happen here, right? Maybe they're both positive numbers, right? 5 is greater than 3. Maybe one's positive and one's negative. 5 could be greater than -1. Or maybe they're both negative, right? -1 is greater than -3. But looking here at the second equation, I think I can rule out this both negative condition, because if that's a negative number and that's a negative number, then surely after doing all these operations, we're going to get another negative here. So they're definitely not both negative. And then looking here, it doesn't matter if y is positive or negative. We are, after squaring it, going to get a positive number. And so if we're subtracting a positive number, and we have this kind of x times y at the front, I do need this to be a bigger positive number so that once we do positive minus positive, again, this one being bigger, we still get a positive result so that we can actually square root it. I'm assuming we're not working with imaginary numbers here, and so I don't think it would make sense for us to start with a negative number on this side and then subtract even more to get, a negative radicand there underneath the square root sign. And so to make x times y positive, we would either need them both to be positive or both negative. We already ruled out that both negative looking at the second equation. So this at least tells me that I should expect some scenario where x and y are both positive numbers and x is bigger than y. So just a little kind of overview of what's happening with the variables, just to make sure that once we do get our answers, the numbers line up with the expectations here. I think to start solving, let's just take this first equation and then remove the fraction. I'm going to multiply the denominator to the other side, so we get x minus y is equal to 2 times root xy minus y squared. Here, seeing the square root, maybe squaring both sides would make sense, so we get x minus y squared is equal to 4 times xy minus y squared. Let's expand and distribute stuff just to see if that helps at all. So I'm expanding the left side. Ooh, if you didn't notice, we were just joined by Quill. He has some ideas to share as well. And then let's distribute the right side. We get 4xy minus 4y squared. I'm seeing some similar or the common terms on both sides of the equation, so I think it would be useful to collect up those like terms. So I'll subtract a 4xy from both sides, and then I'll add a 4y squared to both sides, and this should all equal 0. I think this is factorable. I'm thinking back to this kind of easier trinomial, and I know that this is going to factor as x minus 5, x minus 1. So I think for this one, I could do x minus 5y, and then x minus, 1y, which I could just say y. And if you wanted to, you could distribute out all 4 of those terms, and we will get back to where we started. This factored form is helpful because if I have two things multiplied that equal 0, surely one of those two factors must be that 0. And this condition over here, actually, we can get rid of, because if x minus y is 0, then that has to be 0 on the right side. Or I guess maybe we would get some kind of undefined fraction, because I think we'd also be dividing by a 0 right there if x were equal to y. And I don't think we can do that because, again, x equals y will give us a 0 over 0. That's no good. And so I can rule out this factor right here being 0, and it must be that x minus 5y is equal to 0. Now we can just kind of look at the two linear equations that we have right now. X plus 3y equals 24, and then x minus 5y is 0. Let's do a little elimination. I can subtract one equation from the other. The x's are eliminated, and then 3 minus negative 5y is 8y. This is equal to 24 minus 0, or still 24. So great, y is equal to 3. And then we could use this 3 and plug it back into either of these equations. I'm just going to use this one because that was the one that was given to us. X plus 9 is equal to 24. And then that shows me, after subtracting 9 from both sides, that x is indeed 15. Just for added confidence, I do want to plug in the 15 and the 3 into our first equation, just to see what happens. So we do get 15 minus 3 on top. That's going to be equal to 12. And then we get 15 times 3, that's 45, minus 3 squared, so minus 9. This is the square root of now 36. That is the number 6. And then indeed, 12 divided by 6 is 2. So these two numbers, 15 and 3, do satisfy both equations. And we're done. And 15 is today's date, so it all worked out. So thanks for watching. I'm all done. Hope you enjoyed, and I'll see you tomorrow. Bye.